everyone. Welcome so much to the Chaos Engineering Workshop. Really appreciate everyone taking the time to join us here today at re:Invent. Hope you've had a good start to your week. My name is Iris Shu, and I'm a Senior Technical Product Manager with AWS Reliability Services. I'm joined by Vlad Nanosekin, who is a Principal Solutions Architect with our AWS Global Financial Services. And whether you're here because you're responsible for maintaining a perfect customer experience and uptime for your application, or you're looking for help with complying with compliance requiremements for scenario testing, we hope you'll be able to take away something useful and important today. So we'll give a bit of context first about the what and why of chaos engineering, but we really do want to spend the bulk of these 2 hours getting hands-on with chaos engineering. And so by the end of this workshop, we hope you'll be able to really take away an understanding of using chaos engineering to boost your confidence in the performance and reliability of your workloads. I just want to start with a simple question, which you'll probably hear in most of our resilience-related sessions, but how do we build systems that never fail? Can we do this? No. And that's correct, because so we cannot, because systems will eventually fail. And it's what happens when systems fail that matters, and that's why it's really important to build and architect and operate with resilience in mind to be prepared for those failures. We have this mental model for thinking about resilience, which is the ability of a workload to respond and recover to a disruption in service or infrastructure. So on one side, we have high availability, which is the ability to operate in a primary site and recover from any disruptions at a primary site. Sometimes in the rare events where that's not sufficient, that's where disaster recovery comes in. And that's the process of failing out of a primary site and being able to recover and resume normal operations in a secondary site. Underpinning all of this is the idea of continuous improvement and following best practices of CI/CD and integrating chaos experiments continuously. Combined with the mental model and years of AWS experience working with our customers as well as our internal teams, we've developed this resilience life cycle framework, which has 5 stages for really thinking about how to approach resilience on the cloud. We're really just focused today on the evaluate and test phase of this life cycle today, but at each phase, there are different best practices, AWS services you can use, and mechanisms. So to learn more, I really recommend checking out the link there. But again, we're just focused on the test phase, which is just one piece of the whole pie. Now, why is this test phase important? Well, running chaos experiments is the process of stressing an application to observe how it responds and verifying whether or not your assumptions about that application response matches your initial hypothesis. Just a quick show of hands here. Who here is not super confident that they have the right observability and alarms in place to detect issues in an AC? And who here is unsure that their runbooks are fresh and up to date? So if you look around the room, you're definitely not alone here, and that's where chaos engineering can be a useful tool to address some of these gaps. So in addition to some of the benefits, such as improving the reliability and availability of your applications, chaos engineering can help cover any hidden issues, which is really important in the large distributed systems that you may be building, exposing any blind spots you have in your monitoring, observability, and alarms, and definitely, last but not least, practicing the operational skills in your runbooks. So you really want to practice those, build that operational muscle, and chaos engineering can help with that so that you build a culture of resilience in your organization with the people and processes. Now, the way we do this on AWS is with Fault Injection Service, a managed service for running these experiments. And we really think of our roadmap in these 3 main pillars here. First is that we want to make it as easy as possible for customers to get started. So running an experiment as easy as a few clicks in the AWS Management Console But when we see that once customers get pretty comfortable with the types of experiments that they want to run, they can then run it more continuously using infrastructure as code and integrating with their pipelines. The second, and this is kind of the bread and butter of FIS, are our real world conditions. So we have over 30 native faults and that you can only find on AWS. And we also have a scenario library. You'll be working off of the scenarios in the scenario library today. So this is our answer to customers asking us, how do I get started? What should I test my application against? And finally, running chaos experiments. It's not just about injecting chaos into your system, but running experiments in a controlled way. And so you can do that by defining who can run experiments as well as what they can do with IAM policies. And we have multiple safety features such as alarm-based stop conditions and safety lever to stop experiments at any time and safely roll them back. Now, running chaos experiments is a guided process, and you might be familiar with this because it's essentially the scientific method. You'll start by understanding the steady state of your system, forming a hypothesis about what will happen to that steady state. Once, for instance, if there's an instance that is terminated, that your application can remain available, then you run the experiment to verify if your hypothesis was true or not, make any improvements based on your learnings, and repeat again. So as you go through this workshop today, I hope you keep this life cycle in mind because it will be a helpful framework to thinking about the experiments you're running. So I'll now pass it over to Vlad to give some context that will be useful for this workshop.
Thank you, Iris. So let's talk about real-world applications and what you will see in the workshop today. First, I would like to start with a question. How many people here have pets? How many of you have dogs? And what about cats? Okay, we have an audience who love animals. And in this workshop, we decided to use real applications that allow people like yourselves to adopt a pet. And when we think about this application, a simple user journey for a person who would like to find a pet for adoption and actually get it adopted will be quite simple. You will have user interface where you will see all those pets, but you might want to look for a cat, or for a bunny, or for a dog of a particular breed. So we have to have such capabilities. Then you would like to make an adoption, pay a fee, and you would want to ensure that all of this is preserved in a database. This looks quite simple, just 4 components. But when it comes to building this application, your technical architecture may have significantly more components. Like in our case, we used a variety of services deployed on AWS. Our UI is running on EKS using EC2 as compute capacity. Our Sage capabilities are running on ECS using EC2 as compute capacity. Our payment and adoption service are running on ECS using Fargate. We have RDS as a store for the services, for the records, and we have some regional services like S3, DynamoDB, and Lambda to perform some additional functions. If you would like to go multi-region, this will become even bigger. So now you have 2 stacks of your application running in multiple regions, and they need to stay in sync. So we have S3 cross-region deprecation, we have DynamoDB global table, and we have transit gateways allowing traffic to go from one region to another. Like Iris said, lots of customers asking us, so how do we get started? We have quite a complex infrastructure, we don't know what to do. And that's where a scenario library comes to help our customers. Because we used our experience, we used our knowledge to build those scenarios, combining different experiments in the right sequence with the right duration. So let's take a look on one of those, and that's AZ power impairment scenario. If you will again look at this application, it deployed creates 2 availability zones with a variety of services. And we don't need to go and figure out how to interact with them, what will happen if AZ will lose power. With the help of scenario library, you can easily create a template. And again, like Iris said, in one click, you run the experiment, which renders the whole AZ being impaired and unavailable. Iris also mentions that we have native faults, which makes FIS somewhat unique. So we won't go into all the details, but we will just give you an idea why it reflects the real-world scenarios. One example of AZ power impairment and ECS EC2 autoscaling groups. So when you look at their autoscaling groups, and in our case we have two of them, autoscaling will be responsible for providing enough capacity for your application to run as smooth as possible. And when you need extra capacity, your autoscaling group will communicate with autoscaler asking for extra capacity. Autoscaler will balance your compute against multiple availability zones to ensure as much availability and resilience, and it will get this instance provisioned. And this process will repeat as many times as you need. When it comes to running an experiment, when FIS will impair one of the availability zones, first of all, what will happen is resources will be impaired. They will disappear. Autoscaling group will realize that it lacks required capacity, and it will go back to autoscaler asking to fix this. Autoscaler doesn't yet know that there is a problem with this availability zone, because like any other system, it runs health checks. So the best thing that we'll try to do is, again, to balance this capacity and provision required EC2 instance in the impaired availability zone. But this will not happen because it's offline. There is no power, so you can't provision an instance. But it will still wait or try to do its job as many times as it takes before the health checks will kick in, and then autoscaler will realize this zone is unhealthy, so I can't use it. And it will provision required capacity in the other availability zone. The other beauty of FIS is that once your experiment is over, you don't have to do anything. You don't have to preserve your state. You don't have to actually do anything. When experiment will be over, your application will return to the same state as it was before. Very similarly, when it comes to another scenario which we have, cross-region connectivity, when FIS impair your region, it essentially isolates this region from the rest of your infrastructure. Again, creation of the experiment is very simple. You go through scenario library, you create a template, and then you execute it. As part of the execution, FIS will break S3 cross-region replication, so your S3 bucket objects will not be replicated between two regions. Your DynamoDB table will stop replicating as well. And transit gateway will not be able to communicate with impaired region. Very easy to set up, very easy to run. And once again, it's based on our experience and understanding how all those services will behave. Once experiment will be finished, again, you don't have to preserve any configuration. FIS will do it for you. It will restore your services exactly to a state how they were before the experiment. When you will go through the workshop, we would like to ensure that you will take something away from this session today. And as a takeaways that we would like you to consider would be proactivity in doing resilience testing with chaos engineering, experimenting, finding potential issues, and making sure that you make improvements on them. Before you do run your chaos experiments, you also need to think about your goals. What exactly you try to achieve? How are you going to achieve it? And what will be the expected outcome? Importantly, you don't do it once. Like Iris said, resilience is a continuous journey. So you continue to iterate and ensure that your application stays resilient through its life cycle. During the workshop today, we will show you 3 experiments which you will be able to choose which one you will go through. 2 of them will be based on scenario library. 1 of them will be our recent addition in a serverless world, FIS Actions for Lambda. But it's not the whole set of experiments that you can run. Like Iris mentioned again, there were like 70 integrations, was it 70 native calls? Yeah. So our workshop contains a lot of experiments, and we will encourage you after reInvent to go and explore it again. Reach out to your account teams if you would like some help and guidance from AWS, or do it on your own. There is an option how you can run this workshop in your own environment. Just bear in mind that you will have to cover the costs. On this note, let's try to get our hands dirty and do some hands-on exercises. Through the workshop, we will again would like to set a few goals for you. First of all, run those tests, run those experiments. Workshop has observability in place, which you will see during the workshop. Again, that's not to say that this is the best observability you can achieve, but it will give an idea of the baseline and what you should be aiming for. And every experiment that you will go through will have its hypothesis, assumptions, and outcomes, with the whole purpose to learn something from the experiment. So let's get started. For this experiment or workshop, you'll be provided with AWS account. So if you have your own account, make sure you log out from it. Make sure that you will use account provided by us. We also have seen some issues in previous workshops when some Cisco engines or like other software has been blocking access to AWS environment, especially if attendees were using corporate devices. So if you will have an issue, we have my colleagues supporting you, so raise your hand and we'll come by to fix it. They are all around, so don't hesitate. If anything unclear, just raise your hand. To start the workshop, you will need to go to this URL that you can see on the screen, join workshops.aws. Make sure that there will be workshops, not workshop. And then you'll be asked to provide an access code. So access code is on the screen. You will be also asked to go through the OTP. We would recommend to use an email address. We will not spam you, we just need to confirm that you are a human. You will receive a code that you will use. And once you will confirm the code, you will just need to accept terms and conditions, and you will see an interface for the workshop that I will show on the screen in a few minutes. reInvent workshop will have 3 labs: AZ power experiment, regional connectivity, and Lambda actions. You are free to choose any of those labs, and you can do as many of them as you can fit within allocated time. If you're comfortable, move along with yourself, like just proceed with the speed that you're comfortable with. I will show you one of the experiments on the screen. So if you just started with FIS, you're not sure how to work with it, you can follow me on the screen. It's up to you.